Okay, so you know how we always talk about 1.5 degrees of warming as this like big scary threshold, right?
Right.
Well, today we're going even further than that.
Oh, really?
Yeah, we're diving into this paper that came out recently in PLOS Climate.
Okay.
And get this, the title is Proposing a 1.0 degrees Celsius climate target for a safer future.
Whoa. Okay, so even more ambitious than 1.5.
Exactly.
Yeah.
Like, are we setting the bar too high, or is 1.5 actually not enough anymore?
Well, that's what this paper is really arguing for, right?
Yeah, let's get into it. So, who are the folks behind this kind of radical idea?
So the lead author is Christian Breyer, and he's got a bunch of colleagues on this paper as well.
And their main point is that 1.0 degrees is actually what we should be aiming for, not 1.5.
Yeah, they're making the case that 1.5 is actually maybe too risky.
Okay, so why 1.0? Why is that the magic number according to them?
Well, they start by pointing out that the IPCC, the Intergovernmental Panel on Climate Change.
Yeah, the big authority on climate science.
Right, exactly. They've already found that we're seeing significant damage from climate change right now.
And we're only at like 1.2 degrees of warming right now.
Right, which is why they're saying, hey, even 1.5 could push us past some serious tipping points.
Tipping points like those things we hear about that could kind of make runaway climate change unstoppable.
Exactly. Once we hit those, it might be impossible to reverse the changes.
So what specifically are they worried about happening at 1.5 degrees?
Okay, so one of the big ones, and this is really scary, is exceeding safe wet bulb temperatures.
Wet bulb. Okay, remind me what that means again.
So basically, it's a measure of heat and humidity combined.
Right, right.
And beyond a certain wet bulb temperature, your body just can't cool itself down anymore, even if you're sweating like crazy.
Oh, wow. So even being in the shade with plenty of water won't help.
It's like your body's cooling system just shuts down and it can be deadly.
Yeah, I remember reading about some cases where that's already happening in some parts of the world.
Right. And at 1.5 degrees, those kinds of deadly heat waves could become way more common.
That's terrifying. Okay, so that's one big risk.
Yeah.
But what else are they concerned about?
Another huge one is the melting of the Greenland and West Antarctic ice sheets.
Oh, man. Yeah, those are the massive ones that everyone's worried about.
Exactly. And if those were to melt completely, we could see over 10 meters of sea level rise.
10 meters? Are you serious?
Yeah, it's almost impossible to comprehend, but the paper states that that kind of sea level rise would be an existential threat to coastal cities and low-lying nations around the world.
I mean, 10 meters, that would completely redraw the map of the world.
Absolutely. They even list out some of the cities that would be most at risk.
Like which ones?
Well, you're talking about places like New York, Rio de Janeiro, London, Amsterdam, and the entire Netherlands, Lagos, the Nile River, Delta, Dubai, Mumbai, Bangladesh, Vietnam, Jakarta, Shanghai, Tokyo, Sydney.
It's basically every major coastal city on the planet.
Yeah, we're talking about potentially displacing hundreds of millions of people. It's just mind-boggling.
Okay, so rising sea levels, deadly heat waves, anything else?
They also highlight the risk of disrupting the global thermohaline circulation.
Okay, now that one I'm not so familiar with.
So imagine it like a giant conveyor belt in the ocean that moves heat around the globe.
Okay.
It's basically the planet's central heating and cooling system, and it also helps circulate nutrients in the ocean, which is crucial for marine ecosystems.
Gotcha. So like a vital part of how the Earth regulates its climate.
Exactly.
Yeah.
And some studies suggest that by 2040, ice melt from Greenland could disrupt this circulation.
2040, that's really soon.
Yeah. And the impacts of that disruption could be huge changes in weather patterns, impacts on ocean ecosystems. We're only beginning to understand how interconnected this all is.
So not just sea level rise, but messing with the entire climate system.
Yeah.
Wow. Okay. So on top of all that, we've got the more familiar stuff like extreme weather events, right?
Oh, yeah. The paper definitely doesn't downplay the risks of more frequent and intense heat waves, heavy rainfall droughts, and major hurricanes.
All those things that are already starting to cause so much damage.
Right. And they point out that we're already seeing changes in the jet stream, which can contribute to these extreme weather patterns and even affect global food security.
So 1.5 degrees of warming is starting to sound like a really, really bad idea.
Yeah, and the authors of this paper don't mince words about it. They state that a safe climate for civilization is below 1.0 degrees Celsius.
That's a pretty stark statement. They're not messing around.
Nope. They're saying we need to limit any overshoot of 1.5 degrees as much as possible and then work towards bringing temperatures back down to around 1 degree of warming by the end of the century.
Wow. So not just stopping at 1.5, but actually trying to reverse some of the warming we've already caused.
They even talk about the possibility of active climate restoration in the long term.
Okay, so let's say we agree that 1.5 degrees is too risky and we need to aim for 1.0. The big question is, how realistic is that?
Well, this is where things get really challenging because according to this paper, we've probably already blown past the carbon budget for 1.5 degrees.
Wait, what does that even mean? We've already used up our allowance for emissions.
Pretty much, they're saying that the amount of carbon dioxide we can still emit and have a good chance of staying below 1.5 degrees is likely gone.
Alrighty. That's crazy. How they figure that out?
They looked at the latest IPCC report, which estimated that we had about 300 gigatons of CO2 left to emit from the beginning of 2020 for an 83% chance of staying below 1.5.
Okay.
But there's a big catch. They highlight a significant uncertainty of around 220 gigatons.
So it could be way less than 300.
Exactly. And considering that global emissions are currently around 39 gigatons per year.
Yeah, we're blowing through that budget pretty fast.
Right. So they're suggesting that if you take that lower end of the uncertainty range into account, we may have already exceeded the 1.5 budget early in 2022.
So even 1.5 is probably out of reach at this point.
Yeah, it's not looking good. And that's just to hit 1.5. We're talking about aiming for 1.0 now.
Right. Which seems almost impossible at this point. But is there any hope at all, according to this paper?
Well, they don't sugarcoat the challenges, but they do offer a potential path forward, and it hinges on two main things.
Okay, hit me with it.
First, we need to drastically reduce emissions as quickly as possible. And second, we need to actively remove carbon dioxide from the atmosphere on a massive scale.
Okay, so the first part, cutting emissions, we hear about that all the time. But the second part, that's where things get interesting.
Right. It's not enough to just stop emitting CO2. We actually have to pull it back out of the atmosphere.
And they have ideas for how to do that.
Yeah, they talk about a whole portfolio of carbon dioxide removal or CDR technologies.
Okay, give me some examples.
Well, they're natural solutions like reforestation, planting trees to absorb CO2.
Right. That makes sense. Trees are good at that.
But they also point out that the potential of reforestation is limited. It can only remove so much CO2, and it takes time.
So what else is there?
They put a lot of emphasis on technological solutions, specifically direct air carbon capture and storage, or DACCS.
DCCS, I've heard of that. Isn't that the one where you basically build giant machines to suck CO2 out of the air?
Yep, that's the one. It's basically like artificial trees.
And then you bury the captured CO2 underground, right?
Right, permanently storing it away so it doesn't contribute to warming.
That sounds super energy intensive, though.
It definitely can be, which is why they tie it to the first part of their solution, a rapid transition to renewable energy.
So the idea is we use cheap, abundant renewable energy to power these DACCS plants.
Exactly. They argue that as solar and wind power get cheaper, DACCS becomes more and more viable.
Interesting. So we're not just using renewables to replace fossil fuels, but also to power these carbon removal technologies.
And they even talk about using renewable energy to power desalination plants, which could provide fresh water for afforestation projects in drier regions.
Oh, wow. So we could use renewables to tackle both water scarcity and carbon removal at the same time?
Right. It's like a double win. And another thing they highlight is the potential for converting captured CO2 into minerals.
Minerals like rocks.
Yeah, basically they're talking about chemically reacting the CO2 with certain types of rocks, which turns it into a stable mineral form.
So it's like turning a harmful gas back into solid rock.
Exactly, which makes the storage even more secure and sustainable.
Okay, so we've got renewables powering DACCS plants and turning CO2 into rocks. It's starting to sound kind of sci-fi.
It definitely is, but the authors argue that this is the scale of ambition we need to be talking about.
So how much CO2 are we talking about removing to hit that 1.0 degree target?
They estimate that we'd need to remove around 40 gigatons of CO2 per year, starting in the early 2060s.
40 gigatons. That's like the same amount we're emitting globally right now.
It's a huge number, but they argue that with continued rapid growth in solar PV and improvements in the energy efficiency of DACCS, it could be possible.
So under the right conditions, they think we could actually pull this off.
That's what they're proposing, and they stress the importance of having a diverse portfolio of CDR solutions combining natural and technological approaches.
So not just relying on DACCS, but exploring all the options.
Right. And they also acknowledge that things could be easier if global energy demand growth slows down.
Which would mean less energy needed for CDR.
Exactly. But they also say that if DACCS turns out to be more energy intensive than expected, it could make hitting that 1.0 degree target a lot harder.
So there's still a lot of unknowns.
Yeah, there always are with these complex global challenges. But the point is, They're trying to shift the conversation.
From just reducing emissions to actively restoring the climate.
Exactly. And they argue that we need to be thinking about these things now because the longer we wait, the harder it gets.
Right, so this whole deep dive has been about this paper proposing a 1.0 degrees Celsius climate target for a safer future.
Yeah, and the authors end the paper with a call for a new discourse on climate safety.
They're basically saying we need to stop being complacent and start thinking bigger.
Exactly. And they compare it to the adoption of the Paris Agreement, which really spurred a lot of research and innovation around the 1.5-degree target.
So they're hoping that by putting this 1.0 target out there, it'll spark a similar wave of action.
Right. They want us to move beyond just analyzing scenarios that might not be safe enough and start figuring out what it would actually take to restore the climate.
It's a pretty bold challenge.
It is, but they point out that there's already a lot of research showing that a sustainable global society powered by renewable energy is technically feasible.
So it's not a question of whether it's possible, but whether we have the will to do it.
And they argue that we need to update our economic models and scenarios to reflect the reality of cheap renewables and the potential of large-scale CDR.
So their message is pretty clear. We need to prioritize renewables and demand-side solutions now to set the stage for climate restoration later.
And they emphasize that we need clear and consistent financing mechanisms to support both the transition to renewables and the deployment of CDR.
It's a tall order, but they end the paper on a hopeful note by saying, raising our ambitions to include the kind of world our descendants will want to live in is our responsibility.
It's a powerful reminder that we're not just dealing with abstract numbers here. We're talking about the future of humanity.
Okay, so just to wrap up this deep dive, the authors of this paper, proposing a 1.0 degrees Celsius climate target for a safer future, are arguing that even the 1.5-degree target might not be enough to avoid catastrophic climate change.
Right, and they're proposing that we aim for 1.0 degrees instead, which would require both a rapid transition to renewable energy and massive deployment of carbon dioxide removal technologies.
It's a challenging goal, but they believe it's achievable and necessary to create a truly safe climate future.
And the fact that renewable energy is becoming so cheap is a big reason for optimism. It opens up possibilities that we couldn't have imagined a few years ago.
So the question is, do we have the will to seize those possibilities? And what will it take to overcome the technological, economic, and societal hurdles in our way?
Lots to ponder and lots to discuss until our next deep dive.
Thanks for listening, everyone.
Yeah, thanks for joining us.